So, welcome to today's little newscast. I have three things I would like to talk to you about today. One we will start with in a second, which is the place where I am. The second one is some interesting new thoughts in one of this month's issues of New Scientist. And the third one is some specific news from Euroluna over the last 2 or 3 weeks as such. First, I wanted to introduce you to this place, which is one you find traditionally in a number of Italian old cities, which is the place where people were washing their clothes until some time ago. This one is interesting because there is a very specific inscription here that it was constructed in 1913 and opened by the mayor in order to increase the public health of those who actually wash and do things of that type. It's interesting because it's fun to have a place that now next year will have a 100-year anniversary and is still active, though not used any longer. So with that as a background, let's move to something that's closer to the Google Lunar X Prize competition, which was a very interesting article in one of the numerous issues of New Scientist, which was to use a toolkit of microorganisms to help astronauts colonize another world. In this case, the example used was Mars, where there's been some splicing of relevant genes into cyanobacteria, so they might actually thrive and produce sugar or other interesting building blocks. Food or bricks was the other example that was used in a Martian atmosphere. So you can say some of the philosophical things is those that goes towards going to Mars as colonizers, not as visitors as such. This approach, of course, will not work directly on the Moon where there is no atmosphere, but in principle we could take the atmosphere with us. And of course one of the prizes, the extra prizes in the Google Lunar X Prize, is for finding water, which could then be used for a number of biological processes. Having said that, I wanted to go a little bit to the third thing I wanted to tell you about here, which is the progress in the Euroluna team. And as you may have seen in some of the other newscasts we've made, we've had experiments in the labs in Vienna for our iron engine, the VID engine, and the results were mixed so far that our little power supply, which is between 5 and 10 watts output, is strong enough and good enough to make what we could call a warm start of the iron engine, but was not good enough to do a cold start. Now, since the expectation, of course, is that our satellite will need to be, and spacecraft will need to be stored for a considerable time before it actually gets launched, to have a power supply that's able to do cold start but not warm start is not much use. And over the next period of time we will do what we can to solve that. Two possible solutions have come to mind. One is to move the propulsion lab in form of a vacuum chamber to our electronics lab, and the other one is to do the reverse, to take the electronics labs and move it to, or at least the contents, and move it to the vacuum chambers already existing in Vienna. And that may well be the solution we need to take to solve this issue efficiently and get those number of hours and number of experiments that's needed to find out why our power supply was not powerful enough and what it is for a kickstart we need to apply to our FEEP in space in order to start moving. Thank you very much.